Welcome back to my channel. I hope the videos which I have uploaded are helpful for all of you, and I believe that you all are enjoying my classes. Learning chemistry is nothing but a fun. My dear students, today I am going to start a very important topic in chemistry: acids, bases and salts. This constitute an essential and important unit in high school syllabus of almost all boards and councils. As it is a very long unit, I have divided into several parts. This is a first part which introduces you to different acids and bases in our daily life and also explains the meaning of acids and bases in chemistry. So children, before starting the lesson, I want to remind you to subscribe my channel and press the bell icon. If you find my lesson useful, then please like it. Also, if you have any suggestions to make my lesson better, please feel free to comment. So now, let us start our lesson. Some substances are sour to taste. For example, you can see vinegar, oranges, tomatoes, tamarind. These substances are sour to taste. It is because they contain some chemical substances. Vinegar contains acetic acid, oranges contain citric acid, tomatoes contain oxalic acid, tamarind contains tartaric acid. The sour taste of this food is due to the acid they contain. Acids are generally sour to taste. The word acid is derived from a Latin word, acidus, which means sour. Given below is a list of some substances in our day-to-day life which contain some acids. In our day-to-day life, you can find many substances which contain acid. So here a list is given. Rancid butter, butyric acid; gastric juice, hydrochloric acid; sting of bees and ants, formic acid; sour milk, lactic acid; apples, malic acid; olive oil, oleic acid; fats, stearic acid; urine, uric acid. Children, all these substances they contain some acid, and that is why their taste is sour. But you must not taste all acids for its sourness. It is because some of the acid like hydrochloric acid, sulfuric acid are highly caloric. Look at these substances now. You can see soap, detergent, hand wash, Colgate, antacids. All these are bases. So what is a base? According to one of the scientists, Arrhenius, base is a substance which furnishes OH- ion as the only negative ion in its aqueous solution. Bases are generally metallic oxides or metallic hydroxides or ammonium hydroxide, and these substances react with an acid to form salt and water as the only product. Let us take one metallic oxide, lead monoxide. Lead monoxide is a base. When it reacts with acid like hydrochloric acid, it gives us salt, lead chloride and water. Similarly, metallic hydroxide like sodium hydroxide, it is also a base. When it reacts with acid like HCl, it gives us salt, sodium chloride and water. Then ammonium hydroxide is the third type of base, that is ammonium hydroxide. When reacts with HCl, it gives a salt, ammonium chloride and water. Then another word we will see here, alkali. Alkali is a water soluble base. Now children, one thing I want to tell you, bases may be soluble in water, some of the bases are not soluble in water. So those bases which are soluble in water are known as alkali. So some bases are known as alkali and they are water soluble. From this we can get some examples: sodium hydroxide, potassium hydroxide, calcium hydroxide. All these are alkalis. So all alkalis are bases, but all bases are not alkali because all bases are not soluble in water. Water soluble bases are called alkali. Already we know that one. Now alkalis have a bitter taste. Soap, detergent, or baking soda, all this, if you taste, it will have a bitter taste. The change, they change red litmus blue. Then also they change methyl orange yellow and phenolphthalein pink. They are smooth and slippery or soapy to touch. You take the example of soap. It is very slippery and smooth, so it is a base. Some of the bases are corrosive to skin, like caustic soda and caustic potash are corrosive to skin. So they are very strong base and they are corrosive to our skin. They damage the skin. Now we will come to the theories which explains acid and bases. There are three main theory about acids and bases, and those are namely Arrhenius theory, very common theory, then Lowry-Bronsted theory and Lewis theory. These are the three main theory which explains the meaning and definition of acids and bases. So we will just see briefly the explanation given by this theory about acids and bases. First of all, we will go to Arrhenius theory. Arrhenius is a Swedish chemist and he put forward a theory of acid and base in 1880. According to him, acid is a substance which in their aqueous solution furnishes H plus hydrogen ion or H3O plus hydronium ion as the only positive ion. And base is a substance which furnishes OH minus ion in their aqueous solution. So first of all, we must know children what is aqueous solution. A solution in which water is the solvent is known as aqueous solution. That means when we dissolve acid in water, it produces either H plus or hydronium ion. And when we add a base in water, it gives OH minus ion. So finally what we can say, acids are H plus producer and bases are OH minus producer. For example, you can see here HCl is an acid, so it gives H plus and Cl minus. On the other hand, H plus water gives H3O plus, so that is why HCl is an acid. Similarly, base example we can take sodium hydroxide. When dissolved in water, it gives Na plus and OH minus, and potassium hydroxide when dissolved in water gives K plus and OH minus. So sodium hydroxide and potassium hydroxides are bases. Now the next theory, Lowry-Bronsted theory. This theory was given by two scientists, Lowry and Bronsted, and according to this theory, this theory is very simple, and according to this theory, an acid is a proton donor. Proton means H plus ion and base is a proton acceptor. For example, you can see the example of ammonia when dissolves in water. Ammonia when dissolves in water, it forms ammonium ion and hydroxide ion. Here you can see ammonia receives a proton and that is why it is a proton acceptor, and proton acceptor is a base. Similarly, the water donates a proton here, and water donates a proton here, and that is why water acts as an acid here. So it is the water is the acid and ammonia is the base. Let us look at the following two reactions. Here you can find water and HCl when react. HCl donates a proton to water and hydronium ion is formed, and water receives a proton. So water, which is given in blue color, it is a base and HCl is the acid. In the second example you can see ammonia accepts a proton from water and water is an acid, that is why it is shown in red color, and ammonia is a base. Here one more concept we can get: water acts as both acid and base in different chemical reaction. But we know that water is neutral. So according to Lowry-Bronsted theory, we can explain the acidic property of water also, the basic property of water also. But actually water is a neutral fluid. Let us come to the third theory. It was given by Lewis. So Lewis gave a theory of acid and bases. A Lewis acid is any substance that can accept a pair of non-bonding electrons. That means electron pair acceptor is acid, and a Lewis base is a substance that can donate a pair of non-bonding electron. That is, electron pair donor is a base. So you can find here Lewis acid is an electron pair acceptor and Lewis base is an electron pair donor. From this picture it will be very clear. Here B is a species which is having a lone pair of electron and donates this pair of electron to A. So A is the electron acceptor, which is a Lewis acid, and B is the electron pair donor, which is a Lewis base. For example, you can see here ammonia when reacts with H plus ion, hydrogen ion, ammonia is having a lone pair of electron. It is donated to H plus. So electron pair donor. Ammonia is the electron pair donor, which we can say a Lewis base. And H plus is the electron pair acceptor, which is known as Lewis acid. So children, I hope you understand the concept. Go through it repeatedly. Thank you. Have a nice day.